Verkehrsverkehr an der zweiten Ausfahrt verlassen.
Hi, here's Neil, and you're listening to On the Green Fence, and right now I'm in the car driving through a rather small village in western Germany, North Rhine-Westphalia. It's called Hückelhofen, and I'm looking for a rather special house. All these houses here, brick houses, lots of windows. This house that I'm pulling up here right now looks very different. Turn the engine off, get out of the car. All the other houses around here are built with similar architecture, similar shape, but this one sticks out. It's got a different shape altogether. It's more like a cube with a slanting roof, but only just to one side. Yeah, so let's go in, let's see. Ring the doorbell here. Hallo, Neil King von der Deutschen Welle.
Sabine Engels, guten Tag, hereinspaziert.
Dankeschön. Soll ich die Schuhe ausziehen, oder? I'm standing here with Sabine Engels Arnd Houben. Ah, very good. And why am I here? Because other than me, they have built a house that is helping the environment and not harming it. But we'll have more on that later. First, let's bring in some stats to set the scene. According to the United Nations, households consume 29% of global energy. And in the European Union, buildings are responsible for more than a third of the block's CO2 emissions. So our homes, they can be huge CO2 emitters, depending on things like the materials that go into building them and the energy we use when we live in them. So today, I'll be taking a closer look at how we can bring down the carbon footprint of our homes without breaking the bank, if possible. And Sabine and Arndt, before you give me the grand tour of your house, this house is a passive house. Can you perhaps, in a nutshell, explain to our listeners, what is a passive house?
Wir haben keine Heizung,
We don't have any heating system installed here. Basically, our house is heated by the sun.
Nur durch die Sonne.
Okay, maybe we can perhaps look around. It is a stunning house. It's open plan. You've got a lovely kitchen here, dining room and a large living room, and you've got beautiful large windows. Is that triple glazing?
Dreifach verglast, genau. Und dann eben so.
That's triple glazing, exactly. All windows are arranged in a way to let in as much sun as possible. So there are few windows in the north and more windows in the south and west.
Since you mentioned the windows, a lot of people think that you can't open windows in a passive house. But that's wrong. Of course you can open the windows, like in any other house. Of course, the heat goes out then, and you have to generate it all over again.
If we just try and all be very quiet just for a second, because this ventilation system has got to make some noise, right? Let's see if I can hear something. Nothing. Okay, so that is at the heart of this concept of the ventilation system. So I'm just looking here, the two shafts here in the wall. It looked like miniature flying saucers with a hole in the middle, right? Yeah. And there's hot air coming out of this, or is this sucking in air? It's coming out here. Okay.
We have what's called supply air and exhaust air in each room. Here in the living room, we have a supply air pipe in the wall. And in the kitchen, where we cook and it gets hot, we have an exhaust air pipe. These two air streams run through a heat exchanger where the exhaust air warms up the supply air.
And you've also, if we just go over here into your living room, you've also got a fireplace. Do you need that now and again in the winter? Does it sometimes get, too cold where you sort of think, I do need the fireplace? Or do you ever sit in there sometimes with your gloves or scarves or hats on?
Also ab November fangen wir an zu.
We start using our fireplace in November. When the sun goes away, you definitely have to get the fire going in the winter. Otherwise it gets too cold.
Anmachen, weil dann wird's zu kalt.
Okay, so we're going outside now to your stash of wood. So this is your backup for the winter, right?
Yeah, exactly.
And you chopped this yourself?
Yes.
Okay. And I mean, I'm looking here now. This is, what is this, a cubic square meter, or how much is this?
Almost 2.
Almost 2. And that would last you for?
For 3 months, 3 to 4 months.
And the cladding here?
This is the thermal insulation system, which is about 30 to 40 centimeters thick styrofoam panels that are attached to the house's exterior.
Right. So thermal insulation, that's the second component that's very important with passive houses, right? And that's all around the house?
Yes.
Okay. Let's go back inside then. Great. Sorry, my feet. I'm sorry about this. I'm making everything mucky here. You're not having Deutsche Welle back after this. Going upstairs now. And here's the pipe. So this is coming from down below now. 2 pipes. So one for the air leading out and one for the air coming in, right? Okay, but this is like your utility room now, where this is the hot water, is it?
Yes.
So
Exactly. This is our 750-liter hot water tank.
And how is that heated?
By the Solarthermie.
Okay, so you've got solar panels on the roof.
Yes.
And that was also, that's 17 years old, or is this something
Yes.
you've redone?
No.
That was back then as well already. Okay, so the water is heated through solar panels on the roof, and the heating is supplied basically by the sun.
Exactly.
It heats the building up, and you try and trap as much heat in the building as you can.
Yes.
And does that really work to 100%?
No, also natürlich nicht.
Of course, when the sun is not shining for several days, for example, it doesn't heat up. Then we need to fall back on this electric heating here if we want warm water.
Ja, erwärmt.
Okay, so in an emergency, you can go back to electric power to heat the water or other the heating if you needed it. So, but no fossil fuels. You haven't got any fossil fuels.
Right. Natürlich auch der
Right.
Strom.
But of course, the electricity also has to be green then.
But I mean, that's quite remarkable because you're in the heart of coal central here, really. I mean, North Rhine-Westphalia. I just drove by a huge pit for coal. So, but you've got a house that is not emitting anything.
No.
That's amazing. Now, there are just 10,000 of these passive houses around in Germany today. That's less than 0.1% of all houses. And the world's first passive house was built in 1991 here in Germany, in Darmstadt-Kranichstein. Now, you moved into this house 17 years ago. Why did you decide to go for a passive house back then?
After our architect had explained the passive house concept to us, it was clear to us that we didn't want to build any other way. It was a no-brainer for us, and that this is the future. In fact, I was asking myself, why doesn't everybody build like this?
Zuerst war unser erster Gedanke, wir wollten ein Holzhaus bauen.
Our first thought was to build a wooden house for environmental reasons. This also made sense in view of rising energy costs. We're not hardcore environmentalists. Things also have to be affordable. Unfortunately, back then the cost of wood was much too high, same as it is today. And so we opted for a solid construction with bricks. It wasn't that much more expensive than building a normal house. We have about 150 square meters here, and we paid about 1,500 euros per square meter at the time.
And if we look at the neighborhood here, because it's a very small village, right? About 600 people live here. You're the only house that has been built like this. You're really unique. How did the people here feel about this? Is it something where they sort of feel, maybe we'll inform ourselves, maybe we'll go with this? Or is it something where they just sort of feel, no way?
I think we're probably considered to be a bit exotic here. In a small town like this, where the neighbour is a heating engineer and the other neighbour is a window maker, people don't experiment. They build normally.
Sabine and Arndt, thank you very much for your time. That was very interesting. Okay, so I must say I was rather impressed with Sabine and Arndt's house. It was the first time I'd been inside a passive house, and it wasn't cold, the air smelled nice and fresh. I couldn't hear the ventilation system at all, which is something I was initially sort of, concerned about, that might be a problem. The only CO2 emissions they have from the house directly are from the fireplace, which they only use during the winter. But I guess if you're nitpicky, those emissions also have to be factored into the whole equation. And and I know for a fact that my house, there are 5 of us living in it, and it has a gas heating, and that emits around 4 tons of CO2 each year. And that's something that Sabine and Arndt can save with their passive house. But what I don't know is just how big of an environmental, sin I have committed in terms of emissions by building a conventional house made of bricks and concrete from scratch. And that is something I think that's important to know. So I got in touch with Irina Brehme to find out. She's with the German company and consultancy myclimate. And they help you calculate and offset your CO2 emissions in all sorts of sectors, including housing and construction. And she had a rather sobering figure for me.
For a residential building with 150 square meters, considering the whole life cycle over 50 years, the CO2 footprint would be around 320 tons. And in comparison with a net zero building, it would be around 100 CO2 tons, which is not included the individual CO2 footprints of the people living in these buildings.
Now, I must admit, those figures, they do make me feel more than a little guilty and also quite frustrated that I just went with my architect and planner, back in 2014 when I built my house and didn't even consider a passive house because they said it was just way too expensive. Anyway, moving on, just a reminder that nearly 40% of Germany's greenhouse gas emissions are caused by buildings. And that's more than the transportation sector, by the way. And the lion's share is due to the operational emissions like heating. That's because over 3/4 of the buildings in Germany are still heated with the help of fossil fuels. But the building materials that we use in the construction sector are also significant. Concrete, for instance, has a colossal carbon footprint, accounting for more than 8% of global carbon emissions. Now, more passive houses built with more sustainable building materials, such as wood, could, of course, be one way to reduce our future CO2 footprint, but that doesn't really solve the problem that we have with the 42 million residential and non-residential buildings that already exist in Germany. So what else can we do realistically to decarbonize the housing and construction sector in line with our climate targets? And I discussed precisely, this question with Dr. Anna Braune. She's the head of research and development with the German Sustainable Building Council in Berlin. And one of the most efficient fixes she mentioned was really ridiculously simple.
It is the optimization of the energy systems. We know from studies that simply optimizing the existing systems would save 20 to 30% of the carbon emissions immediately, without any changes of machines and without any big investments.
You mean the heating system in the houses?
Mm-hmm.
Let me just get this straight. If I understood you correctly there, if we just, adjust our heatings properly, we can save up to 20% on our emissions.
Yeah. Definitely. So the heating system in general and in total. So it's not just, the degrees, but it's also about, when do you heat office buildings that are heated during the weekends, during the nights. It's the pumps that are not regulated correctly. And so it is a lot of energy that we can save.
Well, let's talk materials then. Okay, so materials. I mean, what should we be doing? What should we be phasing out? I mean, concrete, for instance, has a very bad reputation. Would we solve a lot of our problems if we just didn't build with concrete?
You can already buy concrete that only has half of the emissions than like typical concrete, or you can use concrete with lower masses. So you can build thinner walls and thinner ceilings and so on. So,
but why aren't we doing that? Are we doing that? I mean, if that solution's on the table, why is that happening?
It's not happening.
Why
not
not?
happening yet, because people earn money with selling concrete.
So it is just the business model being forced upon, I don't know, unsuspecting people who want to build a house. They could build it with far fewer materials.
Yes, it is a business model, and of course it is our standards. So we do have security and fire standards which still come from the Second World War, and which cause a lot of usage of materials. So if you tell people, this is stable and this is sound insulating and this is, safe, then people tend to build more. And this is how our standards work. And this is also how people get trained in universities. And, the whole system is like this. Building thinner and building with less is a very good, I would say, concept to save carbon emissions. But yeah, we need a mind change for this.
If we're looking at the materials, we talked about concrete a little bit. What would be the material of the future that you would like us to use a lot more of, to make buildings sustainable?
So today everybody talks about wood, and that building in wood is, the solution for the climate crisis. We need to reduce the area that we're building. So that would be strategy number one. Strategy number two would also be to build for not just for 50 years or 40 years or 60 years, but for maybe 200 years, and that we have more adaptable buildings that are ready for the different futures that are coming. So, and no matter what material we use. So this is, I would say, the prerequisite that you need to clarify. Mm-hmm. And then we can think about which material will we use, like, recyclable materials as well, and recycled materials, less material, and bio-based materials, of course. Bio-based materials, from a climate perspective, have the largest, I would say, potential. Mm-hmm. Wood is storing carbon emissions. And if we manage to keep sort of the wood in the building longer as it would have been in the forest, for example, then we do something good for the climate. But if it's just about exchanging a bad material against a good one and changing nothing else, we won't contribute to the climate targets. And there's many more bio-based materials that we should consider, like straw, but also loam. Why not thinking about taking the earth and using it for building? So it's not just wood, and we cannot continue the whole system just in wood.
Mm-hmm. Mm-hmm. You just mentioned the buzzword recycling. There's also another buzzword with urban mining, that we sort of go into the cities and take out these materials and reuse them for new buildings. How much does recycling contribute right now, and where would we need to get, in terms of recycling materials in the housing sector?
So recycling is defined in a way that the quality of the materials that come out of the recycling process can differ a lot. So some people talk about recycling, and it's definitely downcycling. So 50% of the waste in Germany comes from the building sector. But then people tell you that out of these 50%, 80% is recycled. And then you ask, how are you doing this? Oh, we take the old materials and we put it into building streets. I don't see the environmental benefit of that. But there is recycling that is really saving energy, and with this, typically carbon emissions. And of course, the whole transportation chains and the whole also unethical, I would say, behavior of taking materials from the other side of the globe, shipping it to Europe, manufacturing it, and then putting it into our buildings just to make them a bit smarter. So the urban mining is not just a buzzword. It is definitely a need that we need here in Europe. Europe is quite resource scarce, and it will be not too far future. It will be the most economic way of getting materials and resources.
Let's just bring back Irina Brehme at this point. She echoes Anna Braune that we need a more circular approach to the raw materials we use in the housing sector, and she has some interesting figures here.
The recycled building materials cover a share of 12.5% of the aggregate requirement. So it's by far not enough. And to build, no pun intended, a circular economy, it is necessary to start with the whole product life cycle and product design thinking. So in Germany, up to 16 billion tons of different raw materials abound in buildings and almost as much as the same amount in infrastructure. We need to reconsider our thinking, seeing buildings as a disposable products they are simply consumed. But they need to be seen as raw material banks. Keyword urban mining, basically a resource storage.
So the solutions are out there, and some are rather simple, but like in other sectors, as I've discovered, doing this podcast, we need a change of mindset, sectors where the industry is happy to make money on wasteful and often uninformed consumer behavior, which could be changed a lot faster if the industry offered us solutions that are more eco-friendly, but probably less lucrative. It's a bit of the chicken and the egg situation going on there. But once again, if this is something that the industry doesn't do voluntarily, we'll need more regulation or taxation to address this. It's the same story in the food or car industry, for instance. But anyway, let's move on to our final interviewee in this episode to get a closer look at a potential solution that is on the table when it comes to sustainable construction materials. It's also something that Dr. Anna Braune flagged, loam or clay bricks. So let's bring in Michele Barbato here. He's a professor of structural engineering and structural mechanics at the University of California, and he's been developing a mechanically compressed clay brick that he believes could be a game changer. So let's find out what is so great about these bricks.
Several things. One is the base material is fundamentally free. The cost is extracting the material from the soil, which we have to do anyway, for example, to prepare foundations or whenever we are excavating and moving soil for a road and things like that. In addition to the intrinsic fact that this material is natural and fully recyclable, you have also that has very good properties in terms of insulation, and so you have additional savings in terms of heating and cooling. Mm-hmm. It also produces walls that are breathable walls in the sense that moisture can pass through it, but is regulated by the wall, so that you can ensure automatically a optimal healthy humidity in the indoor quality, in the indoor air that is contained between the 40 and 60% that is considered optimal for human health. So all of these things amount to not only savings in terms of carbon at the level of the construction, in terms of embodied energy, but also in terms of operative energy. You can have savings of the order of 30 to 70% of energy requirements, depending on the climate.
Right. And how are these bricks made? What is the actual production process?
They are obtained by mixing the soil with water and with the other additive that you may need. And then once you are, after you have mixed them, you put it in a compression machine that mechanically produces these bricks with the different molds. You can have different shapes. You can make it architecturally appealing, and then you let them dry and harden for about for a few days before you can safely use it, and then you build it in the same way as you would do with the normal masonry. But there is no firing, there is no heating, so that's the big side of savings in terms of carbon footprint.
And what sort of lifespan have these bricks got? I mean, how long, if I built a house with these bricks, how long will it stand for?
There are examples of structures made with soil and without necessarily the engineering that we are putting behind them that have lived for hundreds of years or thousands of years. The first example of soil buildings are more than 10,000 years old. Typically, when we consider the design of these houses, we are thinking about a 100-year design lifespan, which is significantly longer than the 30 to 50 years lifespan of the typical constructions we are designing for housing right now.
So, I mean, this all sounds fantastic. I'm sort of wondering, why aren't we all living in these houses yet? What are the problems that you're fighting against to, establish this and make this scalable?
Yes, that's a very good question, one that I'm fighting with because there are practical difficulties in the implementation. The practical difficulties are really not technological in the sense that all of the technical problems we are finding solutions when there are any or solutions already exist. The issues are multiple, but they are really more in the implementation side. On one side is knowledge. Not a lot of people know about this type of construction, including engineers, architects, local building officials, lenders, insurers, and that obviously produces a little bit of a difficulty in presenting and obtaining permits and building structures of this type. It also increases artificially the cost because, for example, in the United States, if you want to build this type of structures, usually you need a professional engineer to design it, an architect, and all of them, they need to sign, be paid, and you may still have difficulties in getting a permit. So there is this issue of knowledge. And then there is also the issue that there are very few crews of builders also that are experienced with this type of material, and there is inertia in the construction industry that tends to repeat what they've been doing for a very long time.
Let's just imagine it were scaled and became like, the standard for building, and it really became huge. What would this mean, environmentally speaking, for our planet? You've already said that, it's got a better carbon footprint, but would this then mean that we would be turning our planet into like a crater landscape because we'd have to be digging all over the place to get the raw material?
We are already digging all over the place. We have plenty of material that can be used. There is much more soil than any cement or steel or any other type of material we are using for construction. So from that point of view, actually, soil is a clear winner. In terms of carbon footprint, it is expected that in the next 60 to 80 years, we will need 2 billion new homes, in part to account for the increase in world population and in part to account for the changing of living standards. That's a awfully big number of houses that need to be built. And if we keep building in the same way as we are now, reaching our goal of zero or even net zero carbon is going to be extremely, extremely complicated and probably impossible. So I think it would be a game changer in terms of what we can do for housing, for low-rise buildings, particularly in rural areas that are difficult to reach, where transportation of material from other places is particularly expensive, not only in terms of cost, but also in terms of carbon emission. And the way that I look at the problem of climate change is that this is such a big problem that we really need to use all of the tools that we have in our pockets to address it. There is no silver bullet that will resolve everything, but constructing with the soil could be one of the big helper in reaching our goal of reducing our emissions.
Professor Michele Barbato, thank you very much for joining us here with On the Green Fence.
My pleasure. Thank you very much for having me.
Okay, so time for my takeaways from this episode, and I'm going to have to condense this a bit because there were so many points this time round. So first off, we can reduce the operational carbon emissions in the housing sector by 20 to 30% simply by optimizing the settings on our heating systems, which I think is just unbelievable. Something we can do right away and very cheaply. Number two, more urban mining and recycling is definitely something we're going to need in future. 50% of the waste in Germany comes from the building sector, another staggering figure. So there's huge potential for improvement and more efficiency there, especially if you consider that an estimated 16 billion tons of raw materials are bound in buildings in Germany alone. That's the stat that Irina Brehme had. What else? Regarding any new buildings that we're planning, we could easily build lighter and use way less materials and still have sturdy houses. But the industry apparently has no interest in that yet, according to Anna Braune. And then it's also clear that we need more natural materials. I think the clay bricks example was a very promising and scalable option to improve the footprint of housing in general. But again, there doesn't seem to be enough industrial or political support for this yet. And finally, just coming full circle to the opener of this episode, the passivehouse of Sabine Engels Arnd. From my experience there, I was only with them for a short time, but it seems to be a great house to live in. They've been in it for 70 years and are very happy. And contrary to what many people think, these houses are not freezing cold. They aren't that much more expensive to build than conventional houses, only about an extra 10%, depending on which materials you go for. And according to estimates, I did some digging, the amortization period for these additional costs is at an average of 10 years in Germany. So it pays off rather fast. Anyway, that's my 2 cents for now. Please let us know what you think. Just send an email to onthegreenfence@dw.com. Right, time for me to thank my colleague and producer Natalie Muller and my sound engineer Jürgen Kuhn. And of course, thank you very much to all of you out there for your interest and taking the time to listen to On the Green Fence. My name is Neil King. Take it easy and take care.
On the Green Fence.